Hello. Today we are going to finish up our notes on section 3-4. And now that I've made you do that really hard long division, I'm going to teach you a shortcut and you're going to be mad at me because you're going to be like, that is so much easier. Why didn't you show us that first? So we can use something called synthetic division when we are dividing by just a simple binomial x minus a. And you know that these binomials will often give us our zeros of a quadratic. We've already practiced that, and it's really no different for for a a polynomial. They'll still give us our zeros. So this is called synthetic division, and it's a method used to divide the polynomial by a linear expression in the form x minus a. It has to just be x minus a. The only constant in this expression is that a. And the way that you do that is we're going to take our 3 right there. So x minus 3, and we're going to put it over here and we're going to put it in a little box. Then we take all of our coefficients of our polynomial. So in this case, we have 2, we have 7. We don't have an x term, so we still have to put in that placeholder 0. And then our constant term is -4. So we put in all of our coefficients. And then instead of dividing and multiplying, or dividing and subtracting, we are going to multiply and add. And so what we're going to do is we're going to bring down your first coefficient. It just comes down. And then you multiply. 2 times 3 is 6. Oh, and that 7 should be negative. -7 plus 6 is -1. -1 times 3 is -3. We add. -3 times 3 is -9. And we get -13. And then all you do is you step down. So we started with an x cubed. So we're going to put an x squared here, an x here. And then this last number is our remainder. And legitimately, that's it. I'm going to throw another example on here for you. So let's say we had 3x to the 5th plus 4x squared minus 6x minus 4, and we're going to divide that by x minus 2. So we put, actually, we're going to do x plus 2. So now notice that that is plus 2, which means that we're putting a -2 in the box. And then again, all of our coefficients. So there's our x to the 5th. We don't have an x to the 4th. We don't have an x to the 3rd. But we have an x squared. We have an x. And there's our constant term. And so we bring down our first term. That's -6. That's 12. It's -24. Makes that -20. +40 gives us -34, or +34. Excuse me, when we add +34, and -68 gives us -72 as our remainder. So that's our remainder. And then we step these down: x to the 4th, x cubed, x squared, x. We add in addition signs where we're missing them, and there is our divisor, or our quotient. Okay, so now let's talk about the remainder and what that actually tells us. So let's look at, we're going to do some synthetic division. So we're going to put -5 in our box, and then we've got 1, 10, 29, 24. 1 and -5, -25, -20, and 4 is our remainder. Okay, so we know when we divide, we've got x squared, x 4, and our remainder is 4. Now I'm going to show you how this works. So what if I put a 5 or negative 5 into our equation? So let's say I did p of negative 5. And that means that I'm going to do negative 5 cubed plus 10 times negative 5 plus 29 times negative 5 plus 24. And let's see what we get. I'm going to pop over here to the calculator. Negative 5. Oh, okay. Negative 5 cubed plus 10 times negative 5 plus 29 times negative 5 plus 24. Oh, I didn't go down. Guys, you know, every time I pop over to this calculator, everything negative 5 cubed over plus 10 times negative 5 squared plus 29 times negative 5 plus 24. And we get 4. So when we do this, we get 4. So what that means is that we can actually use synthetic division. And you guys saw that this took me all of like 30 seconds. You can use synthetic division to find a value. So rather than plug in that 5 and go through this whole rigmarole in the calculator, you can actually do synthetic division and you end up with the same answer. So that 4 and that 4 are the same. So now let's look at this in terms, so that's the remainder theorem. So the remainder theorem says that if you take a polynomial and you divide it by x minus a, the remainder is what you get if you just plugged in p of a. So, and on the flip side of that, if there is no remainder, then that x minus a is actually a factor. And so we're going to talk a lot more about factors. Okay, so we have this word problem here. The population of a tortoise on an island is modeled by this function, where x is the number of years since 2015. Use the remainder theorem to estimate the population in 2023. Well, between 2015 and 2023, that's 8 years. So 8 is what we're going to pop into our box. Then we have negative 1, 6, 12, 325. So bring down our negative 1, I get negative 8, negative 2, negative 16, negative 4, and did I do this right? Negative 1, negative 8, negative 2, yeah. Negative 4 and 8 is negative 32. And then when I add those together, I get that there are 293 turtles because that is my remainder. So if I did that, that's the same as taking negative 8 cubed plus 6 times 8 squared plus 12 times 8 plus 325, and then putting all that in a calculator. So 293 turtles. Okay, our last example says, how can we use the remainder factor theorem to determine whether it's a factor? Well, remember, to determine if it's a factor, you have to get a remainder of 0. So we're going to do this again. So we're going to put 6 in the box. 1, negative 8, 16, negative 23, negative 6. And 1 times 6 is 6. Negative 2 times 6 is negative 12. 4 times 6 is 24. 1 times 6 is 6. And ding, ding, ding. That's our remainder. So that means that this polynomial is x cubed x squared, x, and 1. So if we're going to write this in factored form, we're going to write x minus 6 times x cubed minus 2x squared plus 4x plus 1. And that is our factored form. Okay, let's look at another one here. This one we're going to have to put negative 3 in the box. And we get 1, 0, because there's no x to the fourth, negative 5, 9, negative 1, and 3. We get 1 and negative 3. Negative 3 and 3 is positive 9. 4 and negative 3 is negative 12. Negative 3 and negative 3 is positive 9. And 8 and negative 3 is negative 24. So we have a remainder of 21, which means it is not a factor. And again, we're going to practice a lot more with these factors, and you're going to get plenty of practice in synthetic division. I know I went through that rather fast, but you know I'll do one slow in class for you. But just make sure you have these notes down.